We're live. My guest today is Neel Somani. Neel is the founder of Eclipse. It's a customizable rollup provider for building decentralized applications. In today's conversation, we'll discuss what is a rollup and how it makes sense in the context of modular blockchains. We'll talk about how developers can choose between rollups, app chains, and smart contracts, and what are the trade-offs there. We'll talk about Eclipse and DA layers. We'll also talk about Eclipse and Ethereum ZK rollups and making sense of the modular architecture at a high level. I'm also dying to find out why he thinks settlement makes no sense as a business, and that includes Ethereum. So before we get started, make sure to hit the like button, hit the notification bell, and subscribe to get notified when I go live every week. And remember that none of what is discussed here on the Interop is investment advice. And if you enjoy this content, please consider staking with us. We're live on Quicksilver, Evmos, Osmosis, and Juno. Just look for Interop in the active set. And I hope you're coming to Paris in a couple of weeks because Nebula Summit is coming on July 24th and 25th. It's 2 days of technical talks about Cosmos, IBC, the Interchain. It's going to be great. And I'm really looking forward to it. And I hope you are too. So go to nebula.builders to get your tickets. My guest, Neel, is coming up next right here on the Interop. Hey, Neel.
Hey, Seb. How are you?
Good. How are you?
Going well. Thank you for having me.
Yeah, I'm really excited to talk about Eclipse today. We've touched on rollups quite a bit here on the podcast. We've talked with a lot of execution layers, actually. So we did a couple episodes about that topic, and we've also had Celestia. But we haven't really discussed that middle layer where I think Eclipse sits, which of among other things is settlement. So we're going to dissect this layer of the stack today, hopefully, and talk about a whole bunch of other things. But yeah, before we get started, how did you get interested in this topic and wanting to build Eclipse?
So I was previously building an EVM on Cosmos. Unlike like Ethermint or some of these other ABCI client implementations, this was intended to execute EVM bytecode natively within the Cosm WASM VM. So the WASMer VM would actually execute EVM smart contracts alongside WebAssembly smart contracts. The reason for doing this was Terra was doing really well at the time, so I wanted to bring EVM compatibility to Terra. Wrote some blog posts about it. So I was working on that for a couple of months. And then when Terra depegged, then I stuck around the Cosmos ecosystem, but that project didn't make as much sense anymore, given that there were EVM alternatives that already existed in Cosmos. So I just went back to the drawing board. I was chatting with, I think you mentioned the Celestia team, so I was chatting with them briefly. And Nick White was talking about just the value of rollups and what that can do as far as enabling new types of applications in crypto. And I found that to be really compelling. So I decided to build in the rollup space. And I was in Chicago, so I was talking with a lot of Solana projects in particular. And that's what I found interesting, because even projects in Solana saw a lot of value in having their own chain and then having their own rollup in particular. So that's what I wanted to build for. It's like apps that were really hitting the limits of throughput, but also possibly needed other types of customization or economics that could only be enabled by their own chain.
That's interesting because Solana builds itself as this chain with nearly unlimited transaction throughput. But I guess what you're saying is that, as it turns out, transaction throughput is not the only thing that people consider when building an application. The economics also have to make sense, and aligning yourself with all the different layers of the stack. Like, what were some of the things that people building in Solana were finding difficult about building on this chain that, on the face of it, was supposed to solve all their problems?
Well, at the time, the two compelling use cases or two compelling examples were, one was PithNet. So Pith was an Oracle on Solana. They were purportedly using up like 10% of the throughput, and they decided to spin off their own chain, which is in basically their own SVM fork. It's a full layer one that Pith runs, and they use that as their Oracle network. Then they pass messages using Wormhole. And then another example was Power Ledger, which is also running their own Solana fork. So in both of these cases, the folks running the protocol, either one, felt like Solana's throughput wasn't sufficient, or two, they didn't want to pay that much in rent to a shared network like Solana. Instead, they wanted to own the network themselves. This way they can just incur that cost by running the validators themselves. In Power Ledger's case, it's a proof of authority. And in Pitt's case, I think that they have a little bit less permissioning than that. But the idea is that these folks were going from, like you mentioned, a place that has basically unlimited throughput, but you're a rent seeker and you have to pay Solana for every transaction, to the most opposite extreme, which is when you're the homeowner and they're paying a much higher fixed cost because now they have to run all the validators for this network. And it's likely not economical to do so for an app that isn't running that many transactions, but they have the high fixed cost, but very low marginal cost, effectively zero marginal cost, where every transaction that's running on their own chain, they don't have to pay anything. So those are the two extremes that that monoliths and app chains were basically providing.
Yeah, I think the economics often get overlooked, and we look at blockchains. I think a lot of the narratives around different chains and different ways to organize the modular stack, etc., have revolved around fees and have revolved around throughput and not so much the economics of running an application in a decentralized, censorship resistant way. What are some of the things that developers should consider when considering the economics of an underlying tech stack?
The first thing I try to think about is what would the ideal fully decentralized version of an application look like? So for example, if you look at Helium Network, they actually had their own layer 1 blockchain, which they built themselves prior to the existence of Cosmos SDK. And it was a huge hassle for them to maintain it. But in some ways, it was closer to the ideal in the sense that they were able to run everything on this chain. They had this Oracle network, which now is actually centralized now that they've moved to Solana. And that's going to take some work to decentralize it. So start with that assumption of what's the ideal version of it, and then try to napkin math. What are going to be the hotspots? What are the places that don't really access the same state? Because in general, accessing hotspots are irreducible costs, and there's not really any way around that. Because if you have 10 people trying to access their right to the same piece of state, then you need to have some economically fair way of resolving that. Whereas if it's things that are accessing just different parts of state, then you can basically assign like a trivially low cost to that. And then just kind of sum it up and think about, is that cost something that you need to collect on your own, or is that something that you're okay with paying to some other intermediary? Do you want a hybrid solution where you can borrow the security of something like Ethereum, in which case you might be able to leverage that community, but then of course you're going to pay a higher cost. So you have to think about like, where do you lie in terms of your preference for decentralization, and what's the amount of cost that you're willing to pay, whether fixed or marginal, in order to achieve that.
Yeah, of course, like the spectrum that on the like decentralized to centralized spectrum, I think is an important one and is an important trade-off also when considering what kind of modular stack architecture to build on. We can touch on that a little bit later, I think, but let's talk about the different layers of the modular stack and what is the role of each layer. Like, this is something we've talked about here on the podcast, but I think it's, you know, it's helpful in the context of this show to maybe remind people, like, what are those different layers and what is the role of each layer?
Yeah, it's probably easiest to think through from the perspective of a rollup. So a rollup receives a transaction and it executes it. It computes some state transition. And that's really what a blockchain is ultimately, right? It's some state, you apply transactions to it, and you compute a new state. So that's what the execution function is inherently doing. It computes new states. Then the next part is you have to make those transactions available. This is so that the rest of the network can also keep up and they can independently verify and compute their own state and figure out whether that state matches up with yours. And then the last part, which I meant, this is why I wanted to start with the rollups, which is that there's this last function that some folks dispute whether it's actually like a function of a chain. But at some point, like clients and other folks who are using the network need to figure out what's the truth and what's the version of the state root that we all agree on. And that's the settlement process. So in the case of a ZK rollup, once something is executed and a state root is produced, then in order for that state root to be accepted by the quote unquote settlement layer, then you'd also have to provide some additional proof or evidence that that state root was computed correctly. Or in the case of an optimistic rollup, someone else, like a verifier, can obviously independently execute those transactions, which were made available via the data availability layer. And they can say, I think that state root was incorrect. And they can call for a fault proof and prove or demonstrate that that state root is actually not correct. And then it'll be rolled back. So that's settlement is kind of fraught because the question is, like who's the one who determines settlement and who's the one who determines that canonical chain? Is it the nodes who are running the chain and the users of the rollup? Or in the case of an Ethereum rollup, people tend to think of it as there's some canonical bridge on Ethereum itself, and that's where the proofs are verified, or that's where fault proofs are verified as well. And that bridge on the Ethereum layer 1 is the one that determines the truth or the canonical chain. But the reality is that if something really catastrophic happened on the rollup, or the bridge contract were compromised or something like that, realistically, the rollups community would probably just fork and deploy a new contract, and that would now be the source of truth. So it makes you wonder whether the source of truth is actually the smart contract living on the ETH-L1, or whether it's the folks who are running the rollup, which more realistically, that's what my view aligns with.
So how does each layer interact with each other, and what is the, like, what triggers an interaction between the execution layer and the settlement layer and the settlement layer and the consensus DA layer?
It's all pretty much driven by the execution layer. And execution is a bucket term where for a rollup that typically comprises one sequencer or some logical entity, a sequencer, which is ordering transactions. Then you might have some executor, which takes that ordering, which was committed to by the sequencer, and actually computes the state transition. If you're a ZK rollup, you need some prover or a prover network, which generates the proof for that. And then ultimately, all these pieces are posted to the appropriate places. So for a Validium construction, you might not even be posting those transactions to some publicly available DA layer. Maybe it's some centralized DA or a DAC or something, but it's the execution layer that typically posts that block to the DA layer. And then that state root and the additional evidence would be posted to the settlement layer or passed directly to peers in the case of a sovereign rollup. So it's all pretty much driven by this execution layer.
And so as we go from the execution layer to the DA layer, is there a spectrum of decentralization versus centralization, and risk of censorship resistance versus no censorship resistance?
Yeah, it depends on the part of the stack that you're looking at. So execution, really the key part there is the sequencer, because anyone can execute a sequence of transactions once it's known. So the question is, which transactions were actually included in the sequence? How are they ordered? And that's what the sequencer determines. And that's why the sequencer is often talked about as a point of centralization for rollups. So if the sequencer were the only thing that could let transactions into the canonical chain, then that would be a liveness risk, because the sequencer could just disallow transactions to be included. And therefore, if you're an honest person, you might be trying to get your transaction in and it would never be included. So that's why there's all kinds of other mechanisms like forced inclusion and other schemes that would allow you to insert your own transaction, even if the sequencer doesn't want you to. So that's the first part that could potentially be centralized. And then the second important part is the DA layer. And that's the part where typically there's a lot of experimentation and there's a lot of different points on the decentralization spectrum, where the most extreme would be a completely centralized entity like Google Cloud or an AWS S3 bucket or something. You're allowed to do that, right? You can push your transactions to the internet. Theoretically, it could be censored there. And the other extreme would be the Ethereum L1, where it's quite expensive and it ends up costing something like maybe 15 cents to post 200 bytes on a good day on the Ethereum L1. And that's where the majority of the cost for an Ethereum rollup goes. It's pretty much going to DA, and that's why Celestia identified that that's the biggest bottleneck for rollups.
So yeah, you mentioned, or I mentioned in the intro your hot take, which is that settlement makes no sense as a business, and we were talking about this earlier, and you said that Optimism mainnet pays something like $5 a day to settle on Ethereum. Can you expand on that and why you think settlement makes no sense as a business, and including Ethereum?
Well, just given that Ethereum is like the most expensive layer 1 blockchain, and Optimism is a very actively used. This is Optimism mainnet, so this is the one that's probably handling millions of transactions. It only posts a state root once an hour, basically, and so it's 24 times a day. Ends up being about $5 a day. And that's just not very much money. It doesn't represent scalable revenue, and it doesn't scale with respect to transaction volume. And my view is basically that roll-up frameworks at some point need to collect money from the execution layer. That's the only reasonable play. They could try to compete on data availability, But realistically, the quality of a data availability layer is just the security that it provides, which in the case of a proof of stake network is basically directly determined by the amount of stake that's securing the network. So trying to build your own DA layer compared to someone like Celestia, who's a shared DA layer for many rollups, is likely not going to be competitive. And then settlement, like we were talking about, it's just a bridge really that you're posting state roots to. And being the person who runs that bridge and collects that $5 a day just isn't a profitable place to be. Even if you think that there's going to be thousands of rollups, collecting $5,000 a day, it's still not great. And that's assuming you collect all of you're charging the same amount of Ethereum as Ethereum, and you're supporting all the rollups that exist, which is unlikely. So that's why it leaves execution, meaning that either you need to provide your own sequencer as a rollup framework, or you need to provide your own prover network. If you're a ZK rollup, you need to maybe do the actual executor. Some way you need to capture value from that. Maybe it would be a shared sequencer, or you could partner with rollups as a service and somehow capture value there. But even I'd argue that if you're going to partner with a rollup as a service, more than likely the rollup framework should just have their own in-house rollup as a service, which is kind of what we're doing at Eclipse.
I see. And so, is there like we have there's an increasing number of data availability layers. So we have things like Celestia, obviously, Polygon, Avalanche can serve as a data availability layer, Ethereum. So we have all these L1 chains on which applications can post their state or proofs of the state. Is there enough demand, and do you think that there's going to be enough demand to make it worthwhile for all of these data availability layers to exist? Like I sometimes think about, like is all of this state going to be utilized to its fullest potential, such that like these things continue to exist, be profitable, generate revenue for validators and remain secure?
I think most people would be surprised at using an alt L1 for data availability, unless it's dedicated for that purpose, such as Avail or Celestia, which I wouldn't even describe as alt L1s, given that they're just a completely different product. There's no execution. They're not really competing with Ethereum in that sense. So I think I tend to agree with you that rollups, it's something I thought about too, because like one extreme is Ethereum, but a lot of apps that we support are high transaction volume, but low value per transaction. So it doesn't really make sense for those types of apps to be deployed directly to Ethereum. Celestia isn't quite live yet, and we don't know what that fee, it's a fee market as well. So we don't know what the Celestia block space market will end up looking like. So the other alternative is some kind of DAC or something that's relatively centralized. But then the question is like, is it like more rational to just post those transactions to something like Solana, where it is also pretty much trivially cheap to post transactions to, even if we're using it in kind of a unusual way, which is just to store transaction data. We don't want to use Solana to actually execute it. We're using it as a data availability layer, which you could use any L1 for. And ultimately, I just felt like people didn't really want that feature. I don't think that people wanted to post to use Solana or one of these alt L1s for DA, because then they're viewing themselves as a rollup where one of the benefits is supposed to be that you're borrowing security from some highly decentralized blockchain like Ethereum, and now they're putting on something like Polygon, or I mean Binance was a highly controversial deployment of OP Stack, OPBNB. So I think the technical folks tend not to like that solution too much.
Okay, so you think that the data availability layers will in fact win out on say Ethereum as a data availability layer for rollups because they're specialized? Or is there something else at play here?
I think a dedicated DA layer just needs to provide much more data availability than Ethereum, because the Ethereum DA is just so limited, even after 4844 and after all these different optimizations. Ultimately, like there's just so much demand for DA that fee market might end up being still prohibitively expensive for many applications. So Celestia's play has to be, we can provide like 5 times more or 10 times, some like order of magnitude higher than what Ethereum is able to provide. And then rollups to some degree are forced to use it because it's the only other good DA And what's also nice about Celestia is it's fully verifiable. You can use data availability sampling, and you can make sure that encoding, the Reed-Solomon encoding, is being done correctly and everything. So you can make sure that it's not misbehaving, basically.
Cool. What other trade-offs should developers be considering when choosing a domain, like an L1 data availability layer on which to build their decentralized app?
I think it's really just cost and decentralization. That's really what it comes down to, and it's the most important decision you can make for your app. And what's nice is that if you're on a sovereign rollup or some architecture like Eclipse, then you can always switch that. So that part's kind of a little bit nicer. Technically, you could actually do it for a smart contract rollup too. But the disadvantage is you're still kind of anchored to a specific layer one if you deployed your smart contracts for settlement there.
Cool. So let's talk about app-specific rollups a little bit. And we were talking about this before the show, and you shared some really cool articles that I'll link in the show notes. And there was one article by Electric Capital about understanding the rollup value accrual. Can you talk a little bit about the economics of rollups and specifically like the applications themselves?
Yeah. So when you're on a rollup and you submit a transaction, there's this base cost that you wouldn't pay if you were on your own chain, which is that you have to pay that rent and you have to post that transaction to some layer one and make it available. So that's the biggest cost that anyone incurs when they're on a rollup, and that's the marginal cost. Then there's fixed costs. Fixed costs are things like, in order to facilitate the rollup, you need to have your sequencer running, for example, and that's some hardware. For an Eclipse rollup, maybe it's like $2,000 a month. So that's 25 or 24 grand a year, which must be amortized or paid for through all of your transactions. So if you have 1 million transactions, it's basically nothing, right? If you have like 10 million, that fixed cost gets amortized. So in general, it's less concerning. Another fixed cost is like the opportunity cost of the stake that's being placed. But for an optimistic rollup, maybe the executor has to put down some stake so that if you submit false state roots, then they can be slashed. So that has some opportunity cost, which I'd also throw under fixed cost. There's a bunch of factors like that. And then they're back to marginal costs. Sorry, I made this kind of disorganized. But then there's an execution fee. So let's say there's a bunch of transactions hitting the same piece of state, like we were talking about earlier. Then the execution layer is going to charge a premium for that. And then one more source of revenue for the rollup or for the execution operator in general is MEV. So that could be cross-domain MEV across different rollups, or it could all be within the same rollup or within the same chain. And that's one more place where the rollup can make money. So there's a transaction fee. Part of that is cost. Part of it is the execution fee, which is profit. And then they have some additional money, which wasn't even charged to the user. In some sense, it was kind of indirectly charged, but that's the MEV that they can capture. So that's a high level on how the cost breakdown for a transaction works.
Yeah, talk a little bit about MEV in the rollup space, because this is something that I'm not super familiar with. At which layer of the stack does MEV occur?
It occurs during the ordering. So by the sequencer, because they can remove transactions, maybe they see a liquidations happening. The sequencer can stick their own transaction in. Maybe they see something else that's some kind of profitable arbitrage between two different pools. Then they can take advantage of that arbitrage opportunity. And in the future, maybe we'll see something similar to proposer-builder separation, but for rollups, where you have some big block builders that are basically bidding to include transactions from that sequencer. And you end up with a similar dynamic to what we've seen in Ethereum with flashbots. So that's one direction it can go in. The reality, though, is as far as MEV for rollups goes, or MEV for app chains, is it's effectively zero. There isn't that much MEV that happens for the vast majority of applications. The couple of times where there might be an exception is something like the size of Uniswap. Uniswap probably has quite a bit of MEV that they could probably even recapture for their own protocol, just given that there's so much trading volume that happens. And MEV to some degree is just a function of the trading volume that occurs. So because the more trading volume there is, there's probably more arbitrage opportunities to make just between all those different trades, and there's more constraints to satisfy. So that's kind of the way to think about it. And then even further than that is cross-domain MEV, which is even more far-fetched and doesn't really occur in practice yet. So that's why I feel like a lot of these arguments for shared sequencers around MEV really aren't the reason why they're going to make a lot of money. Ultimately, the shared sequencer is going to make the vast majority of its revenue in the same way that a regular sequencer does, which is just through execution fees.
Right. So it occurs to me that we're talking about like two different types of roll-ups here. So there is a roll-up that can host multiple applications, and in this case, we might have MEV. For instance, like if you're doing a swap, like if you have like an built on that roll-up, and other applications that are interacting with that that AMM. And on the other hand, we have like application specific rollups where here you're leveraging a rollup sort of as an app chain, as if you were your own app chain. Where is that sort of visualization is correct? Like you can have roll up ecosystems as well as application specific rollups.
Yeah, I agree. Yeah, there's like general purpose rollups and app specific rollups, but I kind of view the MEV on those the same way, because ultimately it's just like a set of smart contracts, whether it's the same app or whether it's a few different apps that are each providing their own liquidity pool or something. It can kind of be treated the same way.
Okay, so does it make sense to build an app specific rollup? And like when thinking about the economics and the complexity of doing that, is it the same as building, like it's not the same as like building an app chain and going out and getting your own validator, you're like doing a validator roadshow, etc. Like you do have different considerations when doing an app specific rollup versus an app chain.
Yeah, I mean, the big difference is just that fixed cost difference. So if an Eclipse chain were a full app chain, for example, instead of $2,000 a month for one validator, now it'd be $2,000 a month for 100 validators if it were a Cosmos chain. Or for Solana itself, it's like 3,000 validators. So Solana burns something like $60,000 a month. And this is an underestimate, because the reality is most validators don't just cost $2,000 a month. And then there's opportunity cost of the capital. But Solana is burning like 60 grand a month. Wait, is that even right? Yeah. Well, okay. Yeah, it's basically burning like 3,000 times more than a single Eclipse chain is my point. So yeah, that's the fundamental difference, that you're paying this huge fixed cost when you're running your own L1, because you have to pay for all the validators that are running it. And usually it's paid via inflation. So you have to inflate your token, or you have to somehow compensate those validators for their work. Whereas if you're a rollup, you just have to compensate this one sequencer or one executor, which is typically much cheaper.
Okay. Yeah, I think the semantics are important, because when people talk about rollups and blockchains and app chains, it feels like these terms can be used while meaning different things that might have different levels of sovereignty, a different cost, etc. So, like for example, on Eclipse on the website, you say you're allowing people to build customized blockchains. I was reading that. I was saying like, yeah, kind of, but you can also build decentralized applications that leverage the security of like another system, and that's not necessarily the same as like if you were building your own Cosmos SDK chain. So I wonder, like, do you think that, generally speaking, as a space, like what kind of confusion still exists around the semantics of all these words?
Yeah, that's true. Blockchains is a catch-all term. And yeah, technically, like you could even take a roll-up, and one day you could make it its own sovereign L1 if you wanted to. You can't really go in the opposite direction and take a roll-up and somehow make it a smart contract somewhere. That's a little bit harder. But yeah, I agree that basically it's about what does the user want and what type of app are they building. If they're building a consumer app that's running millions of transactions and they're all low value, there's pretty much no world where deploying to a shared chain would make sense, because those transactions are just too low value to justify paying a transaction fee. And being on their full layer one wouldn't really make sense either, because being on a layer one blockchain means that they have to pay this huge fixed cost, which they likely can't afford. So the only real solution is have some minimal number of nodes, have some settlement process, something like a DAC for data availability. And now this kind of application can finally be enabled on chain in a quasi-decentralized or arguably fully decentralized fashion. So that's the kind of app that makes a lot of sense. Another type of app is just something on Ethereum where they're used to paying high fees and they want to be a roll up on Ethereum, where, yeah, you have that 15-cent marginal cost, which is going to go down over time. And for many apps, that's too high. But if you're a DeFi app on Ethereum, your users are already used to paying like 10 bips or something higher than that. So that marginal amount of cost probably won't make a difference. And you'd much rather capture that yourself as an application, maybe even capture some of the MEV that occurs within your app. So that's another kind of like point in the spectrum and another use case for having your own app rollup.
I mean, do you think that, like, we're talking about rollups here and like this modular stack, and I think like if you go up to the other end to the far end of that spectrum, a rollup can graduate to becoming its own roll app, and then a roll app can graduate to becoming an app chain. And in some ways, like DYDX is an example of that progress from like one construction to another. Do you think there's still room for vanilla smart contracts on a general purpose chain? And is there a graduation path between smart contract and roll up?
Yeah, on the DYDX example, that's an interesting one because actually our chief business officer, VJ, was the head of BD at DYDX at that time, then was the head of BD at Uniswap after. So always a lot of discussion about those guys potentially moving to their own chain. And I think a large reason why DYDX moved to its own L1 is because the app rollup infrastructure just wasn't there at that time. So being on Starcore wasn't really like its own app specific rollup. It was really like a shared chain. In which case, in some ways, you're kind of getting the worst of both worlds, where you're not receiving the rent, so you're still paying to someone else, but you also don't get to you still like don't get to have the full security or just the full decentralization or the argument, the ethos of being on ETH-L1 or the reliability of that. So you almost want to hit something that's either like your own app specific rollup or being on your own like chain which you own, or being on a shared layer one chain. In my opinion, there's not really, I don't see the value in being in one of these shared rollups. And that was really just like an intermediate graduating phase for a lot of rollups. So that's the first point on that. And then the second point is whether there's like a graduation path. I think that's like exactly what you're describing. I think we're going to see it time and time again where people move from some shared chain to a rollup to their own chain. But what's interesting is examples that don't move in that direction, like Helium, where they had their own chain to start, and then they moved in the reverse direction to Solana. But I think if Helium had started with the Cosmos SDK, it's possible that it never would have happened. Because I think a large reason why they moved to Solana is just because the tooling and the infrastructure for their own proprietary L1 just wasn't there. So it was a huge hassle for them to maintain it.
Yeah, I think that also, I think we'll see this reverse graduation happen again, where the cost of securing an app chain, and the app chain thesis, I think was correct in its ethos of having sovereignty over the entire application. But now, with data availability and rollups, I think a lot of those considerations are now less relevant. But the cost will continue to go up. So, like one example that we've been talking about here on the podcast is Juno, right? So like Juno, used to have quite a bit of security when the token was worth $40. Now Juno has something like $10 million securing the chain and stake, but it hosts essentially kind of like the Gnosis safe of Cosmos, which is meant to hold assets. If the cost of attacking Juno is considerably low, that puts those assets at risk. It might be wise for Juno to, people were talking about this on Twitter, that Juno should just like rebrand to DAO chain, and then be secured somewhere else, like move to interchain security, or like become a roll up or something like that, right? And that would make more sense, and it would actually be like quite useful for the community to have that that DAO as a service kind of infrastructure, but at the same time be secured. So yeah, I think probably we'll see that reverse graduation as well, as chains figure out that, like, hey, the cost of securing this thing and maintaining that high level of security is going to be considerably high, and some chains are probably not going to make it.
Yeah, totally agree. And that's why I think if the roll kit go to market should be something like that, which is Celestia's roll up framework, because it's basically taking an ABCI client implementation and turning it into a roll up, which is perfect for taking a Cosmos SDK chain and doing that, or facilitating that reverse graduation. Whereas if you're something like an app or that was on another chain, or like Solana or the EVM, or maybe you had your own bespoke L1, such as what Power Ledger did, then I think something like an Eclipse chain makes much more sense as a graduation path, rather than trying to force all your stuff into a framework that you weren't really using to begin with, which is the Cosmos SDK. So yeah, I think another use case for these shared chains is just that the fixed cost is zero. So if you're a consumer app that's just getting started, it really doesn't make sense for you to pay even $1,000 a month or a couple grand a month. You just need to get started and start playing around with something. And once you realize you've graduated past that point on a shared chain, then you should probably go onto your own rollup or your own app chain or something.
Yeah, this is super cool. I'm really learning a lot here about like the mental model for rollups and app chains. So yeah, let's talk about some misconceptions. What are the biggest misconceptions about rollups in your view?
I think the big one is what makes something Ethereum aligned and what makes a rollup Ethereum aligned. And people don't realize that it really is as simple as you post your transactions to Ethereum and you have a bridge there. And those are the two things that make something an Ethereum rollup versus something else. And there's nothing else. It's not like, yeah, you can have an EVM as well. That might help. It might make you a little more Ethereum aligned. But beyond that, there's no special sauce. And that's why this distinction between smart contract settlement versus sovereign settlement is kind of a false dichotomy. Because ultimately, even if you have a bridge that's anchored to Ethereum, like I was mentioning at the beginning of the podcast, if some horrible thing happens or if for some reason your community just disagrees with the result on that bridge, they're just going to fork and you're just going to deploy another smart contract that agrees with your new consensus, your new social consensus. So that's probably the biggest misconception to me. And then the second misconception is people seem to think that rollups just make everything cheaper. So if you deployed a rollup to Solana or something, that would be cheaper. But just from our argument and the economic thinking that we've been doing earlier in this podcast, you can kind of deduce that a rollup on Solana can't get cheaper than Solana, because now you've just added the fixed cost for running the rollup, which must be amortized over the transactions, and you're still paying for the same data availability, which was ultimately the biggest cost that you were paying anyway. So you're not going to get cheaper than that.
Yeah. I mean that totally makes sense, right? Like if you're building a rollup on top of Solana, you're going to have to add the cost of the data availability to the cost of settlement. And there was this post you sent me by the guys over at DBA, where they argued that like rollups don't exist. Can you unpack that a little bit?
Yeah, so DBA is one of our biggest investors, and yeah, his argument is kind of that ultimately the rollup is just that state transition function, and that's what defines any blockchain or any rollup. And then you all have to be aware of what those transactions that are going into the rollup are. But beyond that, it's not like rollups have some special property where they're borrowing security in any like miraculous way. It just comes down to the assumptions you're making about how the community is communicating information. And that's kind of what that blog post is getting at.
Cool. Yeah, I'll link to that in the show notes. So yeah, let's focus in on Eclipse a little bit here, because we've been talking about this high level stuff since the beginning, but I do want to talk about Eclipse and how it works and how that network is organized and who are the network participants. So I get the feeling like maybe I'm gonna simplify this a little bit. I feel like Eclipse can be summarized as a way to connect different rollup VMs to different data availability layers. It kind of sits there in the middle, and it allows developers to choose the VM on which they're going to build their application, and also the data availability layer on which their transaction data will be posted.
Yeah, that's exactly what we're building. Yeah, that's right. Okay. We picked this machine for the under the hood. It just executes all that bytecode using the same virtual machine, whether it's EVM or Fuel VM, Move, whatever bytecode it is. It's always using this Berkeley packet filter VM, which is highly parallelized, and there's all these nice properties to it. And that's the only like implementation detail that's really relevant for users to know, because it means that they're going to get a lot more throughput than what's available on other chains typically.
So yeah, describe the architecture. So what does it look like, and who are the participants that are allowing this connection between VMs and data availability layers to work?
Yeah, so we basically took the Solana code base and threw everything out but the virtual machine remove the vote transactions, which is kind of a contentious topic. But if you look at Solana's throughput or the number of transactions running through it, there's like some base level of about 3,000 transactions that are just continuously run. And that's because those are vote transactions. So those are the validators that are voting. And I was talking about how there's about 3,000 validators earlier in the episode. So that's basically where that's coming from. So we remove that, given that it's a roll-up and we don't need to do consensus. And you have one instance of that that's running, which is ordering transactions. In the future, that could be a shared sequencer, such as Espresso, who we're working with. But someone orders transactions. Right now, it's that virtual machine. As transactions come in, it's just doing first in, first out. It executes them, produces the result, and then it posts it to the settlement layer. So the settlement layer for Eclipse is basically another rollup, but it's a sovereign rollup. It's an optimistic rollup. So you have some verifiers for that settlement layer, and you have some operators. And they operate in the same way. They order transactions, compute the result, and they circulate this state root. And then you have these verifiers that are basically ensuring that they're being honest. So you have two sets of executors, two sets of verifiers, and the blocks are ultimately posted to whatever data availability layer you chose. That could be Celestia, it could be somewhere else. But what's nice about this architecture is you could remove the Eclipse part of it. So you could have some executor that's just computing state transitions, posting blocks to the L1, to the data availability layer, and anyone can still pull those transactions from the L1, recompute the state of your chain, and they are also a participant of your network. You never needed to touch Eclipse, and Eclipse as the settlement layer is just sitting there as a convenience feature. It's just if you want to rely on some other set of nodes in order to figure out what's the canonical chain, then you can do that.
So can we come back to the network participants? So you have the sequencers and the verifiers.
Yeah. So this is assuming an optimistic setup. So you have a sequencer / executor, which exists for every app specific chain, and you have a verifier for each of those chains, or some set of verifiers for each of those chains. And the state roots that they're verifying are the state roots that were posted to another rollup, which is the Eclipse settlement layer. And that rollup receives state roots. It again has a set of executors, a set of verifiers, and that's what keeps the Eclipse settlement layer operating correctly. And then all these transactions are posted to L1s. And these L1s act as data availability layers. Those are honest majorities, just like a normal L1 operates. So those are the network participants. In the future, there will be more participants where the sequencer might be a separate entity. You might have builders that bid for those sequencers. They might bid to have their transaction included. You might have like RPC operators. There's all kinds of other participants that aren't as like critical. But this is what the system looks like right now.
Okay, so you said that there's a sequencer for every rollup on Eclipse. So
yeah, each rollup gets a separate sequencer. Yeah.
Right. So is that sort of part of the service that Eclipse is providing? Is that like if Eclipse is kind of sequencer, like rollup sequencer as a service?
That's the right way to think about it. Yeah, rollups as a service is kind of a weird term, and I kind of hate the term for the reason that you're getting at, because the core of the business is actually, in the case for most rollups as a service, is providing some kind of isolated sequencer as a service. The alternative is they could also provide a shared sequencer, and those would be competitive with each other. But the thing is that a shared sequencer there's limits to how many chains shared sequencers can support, because the shared sequencer is only as good as the atomic guarantees and the composition that it can provide. And ultimately, in order to provide atomic guarantees and composition, you need to have some awareness of the state across all these different chains. So you need to have some big block builder that's executing all the transactions on all the chains that are being supported, not unlike interchain security for the Cosmos Hub. Very similar. Like you need to somehow have someone who's able to know the state of all these chains, and that ends up being very expensive to do. So each marginal chain, the marginal cost should increase, and the revenue for each chain should decrease, because presumably the shared sequencer picks the most profitable chains to sequence for first, and then each chain thereafter is just less profitable. So there's some break-even point, maybe at like 100 or 200 chains or something, where the shared sequencer it's no longer profitable for it to support additional chains, and those chains will have to be supported by isolated sequencers.
Could that be part of some tiered service offering, right, where you get like shared sequencer for like at a lower cost, the same way that you might have like shared hosting, in Web 2, and then like a dedicated sequencer for applications that are willing to pay for it? Like, does that make sense at all? Or I mean, is it?
I think that's
be a little more
like you'd figure it should be something cheaper, right? Because it's shared. But the shared sequencer gets a little bit of power there, because they're going to be like, why am I doing the work of sequencing for this chain for such a small amount of money? So because likely there'll be some governance process to be included in a shared sequencer, such as the Optimism Supertrain or one of these other shared sequencers that are going to pop up. And that's going to be the decision-making process that they go through. And in the same way as for Cosmos Hub, when they're thinking about whether they should provide interchain security for a chain, in some way you're kind of making a bet on that chain that you're providing validation for.
Okay, yeah, that makes sense. Okay, this is interesting. When it comes, so you mentioned that this is a setup for optimistic setups.
Yeah. So the only difference for a ZK rollup is that now you have some prover network, or you have some set of provers, and those are the folks who are likely alongside the executor who are generating the proofs. So there are these hybrid setups where maybe you submit a state root and it's optimistic until someone submits a ZK proof, and now it's finalized immediately. There's all kinds of hybrids, but in a simplified world, you'd have no verifiers in that case, and you just have provers.
Okay, interesting. Well, so how are these participants incentivized? Like, what are the tokenomics, and who's paying these network participants?
So it's probably easiest to go from cost center to revenue center. So the data availability layer is incentivized because it's just a fee market. So if there's more demand for storing or for making blocks available on Celestia, then the price will go up, and that will incentivize more people to participate. And if there isn't that much demand, then likely fewer people will validate until it basically becomes economical for them to do so. So that's the thinking behind that cost center. The settlement layer and the verifiers, the thinking is that people will run verifiers when they want the chain to run correctly. So if I'm a gamer and I really have a ton of money locked up in this game, then I would run a verifier myself as a player. Or maybe I would have my own RPC node, which is keeping up to date, and I submit my transactions directly to that, something like that. So it's the participants of the network and the community who's running those verifiers. So verifiers aren't compensated is basically what I'm saying with that sentence. And then provers and people who execute need to be compensated for that work. So they would likely be paid some fee, which would the top line is through the sequencers. The sequencer charges the initial fee to the user in order for the transaction to be included, but that fee would be distributed among the executor and provers and whoever else is involved in the network.
So the verifiers are not incentivized because they have an incentive to verify. So I think we've kind of understood that they're somewhat excluded from the economics of how fees trickle down from the application to the DA layer.
Yeah, right now there are. But the tricky part is that it introduces this like crypto economic problem, which is it only ends up being rational for there to be like one verifier. Because if you have two verifiers, now your probability of success is lower, but your reward is not increasing for being a verifier. So it all kind of like converges on these really simple numbers.
Okay, so let's use a practical example. I'm playing some game that's built, maybe it's like a roll app, and it's leveraging it. It's leveraging Eclipse and Celestia. When I have a wallet, that wallet might have the tokens from that game, like the game's economic token. How are the different participants? So the sequencer, and then finally the DA layer. How are they getting paid? Are they getting paid with this in-game token, or is the rollup itself having to do some sort of transaction to convert those tokens into Eclipse tokens, so that the sequencers are getting paid in the native token that they want to be paid with? So that's unclear, I think.
Yeah, it's more like the latter, but it's that the sequencer receives fees and whatever the L3 specified, or whatever the app specific chain specified, and it will do all these conversions in order to pay the DA layer and the Celestia token, for example, It'll do a swap for the Eclipse token in order to pay the Eclipse settlement layer. It'll pay all these different participants.
Okay, so the sequencer generally agrees to be paid in the token of the layer 3, and it has to do this sort of treasury management in order to pay Celestia.
Yeah, another reason why the shared sequencer is basically taking a bet, because they're collecting fees in the native token too for each of these algorithms.
Oh, okay. Yeah, okay. This makes sense. And where does Eclipse make money in all this?
So we're going to have to provide some kind of sequencing, whether it's isolated sequencers or shared sequencer, whether we share revenue with sequencers, but that's the only place that makes sense in my view.
Okay. Can you expand a little bit on your thinking there for
Yeah,
the business
so
model?
we'll have the settlement layer, and you could theoretically, it's a general purpose settlement layer. You can deploy DeFi stuff. There'll be activity there. We'll collect revenue from that as well. I just don't anticipate that will be the bulk of it. And ultimately, the big service that we're providing to people is this roll-up framework. We're providing like all of the tooling for deploying chains very easily, and likely some convenience features for sequencing, because that's the hard part for running all the infrastructure related to a roll-up. You don't want to make it like go on outage if you have to upgrade it. So that's what Eclipse is doing, and the Eclipse network would be compensated for that part. I think that's the core part that a rollup should be trying to capture value in, or a rollup framework. So in these market maps or market segmentations, really, like every rollup framework needs to be in another category as well. Like I hate it when someone says like, "Oh, OP Stack or Eclipse is just under rollup frameworks." We should be there, but we should also be under sequencing or under like some other area, depending on where we intend on accruing value.
Yeah, can you talk about the roll-up framework a little bit?
Yeah, role framework meaning just whoever developed those core components in order to run a roll-up. So whoever wrote the sequencer logic, whoever wrote the virtual machine, the settlement logic, that's software. It's open source. But these companies also aren't charities, so they need to somehow accrue value. That's why I'd push back on the public good narrative a little bit, because roll-up frameworks can't be public goods only. They also need to make money somehow. Otherwise, these projects didn't make sense to invest in. It wouldn't have made sense for even people to buy the token right now.
Yeah. Is Eclipse compatible with any VM, and are there teams like, I mean, I know that Dimension is building this whole roll-up thing that'll allow you to do like Cosmos SDK as a roll-up and EVM as a roll-up. What are some of the other roll-up layer VMs or packages that will be compatible with Eclipse?
So right now we have this highly parallelized EVM, and that's the vast majority of Eclipse chains. And then we also have an option for Solana VM. So that's what we ran for Injective, their Cascade chain, which is a Solana VM rollup for their community. We have a signed agreement with Polygon, with BNB chain, handful of these other chains, and those are all SVM chains. So this is like a way for these different L1s to bring a different virtual machine to their community. They can better capture Solana developers or developers who are more comfortable in that highly parallelized environment. So yeah, that's kind of the reasoning behind why they would want something like that. We have move in development too.
You have move in development too. Who are you working with for that?
That's actually something that Solana Core themselves is actively developing.
Okay, Solana Core is building a move VM.
Yeah, it's move by code for the Solana VM. Yeah.
Oh, okay, interesting. Yeah, what are your thoughts on like the move ecosystem?
I think there's not much of an ecosystem at this point, but move as a language I think is really cool, and I think it's probably something that like it's just a different way of locking and memory management and stuff. So I think it's desirable to have a wider design space for different VMs, and I think that's part of what makes rollup so great. So I mean, it's kind of like Fuel in that sense. Like I think Fuel is also a really interesting virtual machine.
Yeah, we hit Fuel in Epicenter, and yeah, I also thought it was like a very interesting VM. When thinking about interoperability, obviously we've talked a lot about IBC here on the podcast, and like I think as a standard, it is really the only interoperability standard there is today, and it is gaining traction in the space. Help us understand maybe the layers that are interacting with IBC. So if two rollups want to interoperate, like two rollups that are built on Eclipse, would there be some ability for those sequencers to facilitate interoperability between chains, or would you still want to leverage something like IBC for the application so the applications can just send messages to each other? I guess what I'm saying is the fact that two rollups are built on Eclipse, does that facilitate some sort of interoperability that would allow those applications to forego using IBC for like some message passing?
I mean, the best form of composition is via the shared sequencer because that's atomic composition. But definitely next best is IBC, and we're implementing that with Polymer. And actually, there's a couple of efforts going on. I think Skip for some period was thinking about having some sort of IBC validator set where they were somehow incentivized to actually relay the messages, because I think that's an issue for a lot of these IBC chains. Sometimes the messages get stuck lingering there. No one's actually doing the relaying, and that can prove to be an issue in some cases. I think they might have gone back on that plan though. And then Jack Zampolin sent something kind of recently, which is again like an IBC like hub type of thing where it takes state routes from rollups. But to be really useful, we'd want it to re-execute all the state transitions for the rollup too. So it actually achieves finality itself. And just to like take a step back, like what am I talking about? If you look at like an optimistic rollup, optimistic rollups actually never get rolled back. Like the chain itself for an optimistic rollup, the moment you submit a transaction, it's included in that chain. It will never be removed. But what gets rolled back is the bridge. So when you're bridging stuff, that's when achieving finality is important. That's why you have to wait this challenge period on Ethereum, because you're basically waiting some period of time until you have sufficient confidence that there was some honest validator on Ethereum that would have accepted a fault proof. But if you have your own committee, like your own bridging committee, you can just re-execute all of those transactions for an optimistic rollup all the way up to the tip. And you can figure out, all right, this is the correct state route. I know that this thing's never going to get rolled back. And even if some bridge gets rolled back, they're just going to get rolled back and recompute this same state route that we just computed. So that's basically what I would want for like an IBC bridge for an Eclipse rollup. And that's what we're doing with Polymer and possibly what Jack Zampolin's working on.
Yeah, we just had Polymer on the podcast last week, and still wrapping my head around that one, to be honest. I think it's also, I think, sometimes a bit difficult to wrap your head around the mental model of like what Polymer will look like as a network.
Yeah, that's a really good question. And like the economics of Polymer, I'm curious about that too.
Yeah. Cool. Well, yeah, I'd like to maybe take a step back here before we wrap up. And, one thing I'm wondering here is, as the space is really, embracing this modular chain, modular design, architecture and narrative, do you think there's still room for like monolithic chains? And I'm thinking specifically, for example, like Neutron, just launched a few weeks ago, and sells itself as the most secure smart contract chain in Cosmos. Of course, there's lots of other smart contract chains. I mean, we talked about Solana, and Ethereum obviously still continues to exist as a smart contract chain. Do you think these will continue to make sense over time? Is there still like a use case for monolithic chains?
So either in one case, the monolithic chain, especially a new monolithic chain, needs to be prepared to take a loss. And maybe there's some other reason why that chain exists. Maybe it's a public good or something. Or in the other case, you need to napkin math what's the cost of running this chain. If you maybe have a validator that costs 20 grand a year or something, you have 100 validators, then you're burning 2 million a year. So the question is, are you going to bring in $2 million of transaction volume? What's your average transaction cost going to be, your average transaction fee? And how many transactions does that imply? And do you seriously think you're going to get there? And if you don't, then it likely doesn't really make that much sense to be on your own full layer one blockchain. As far as existing monoliths, I think that there's just these network effects that have already been built up. I think that something like the economics of Solana could theoretically work out if they can really like 100x their transaction volume or something.
Yeah, I mean, there's still like tons of monolithic chains and like lots more that are going to launch. Like, I mean, like Aptos and Sui and And like just in Cosmos, there's like 6 or 7 like EVM and CosmWasm and like soon some Move ones. And yeah, I think with the economics is a big question, but also the network effects and will they be able to attract sufficient amount of applications? And yeah, I think probably in 5 to 10 years from now, many of them probably won't be around anymore, or will have downgraded, or it's like this reverse graduation to like some kind of roll up.
Yeah, and if not, then ultimately it's just the token holders who are the losers, because the validators will still get paid. It'll just be the network will be inflated, and anyone who's just paying off their token is going to lose out.
Yeah. And so, what are your thoughts on the Atom Economic Zone idea, and broadly like ICS, interchain security?
Yeah, it's like another point on the fixed versus variable cost spectrum for chains to consider. I think the part that's a little bit like not so great is that you have to go through this governance proposal, and you have to actually like be accepted by the Cosmos Hub. I think another issue is just that I don't know how profitable like some of the chains have been. So even from the Cosmos Hub side, I don't know if it makes a lot of sense. But I mean, that's why I kind of like the concept of a roll up, where if a roll up is paying an L1 money or vice versa, if the L1 is capturing value from a roll up, then they're both benefiting in some way, because it implies that a transaction was actually posted to the roll up and that some user did execute something, and that transaction is not being written just as it's needed, as opposed to an interchain security formulation where a validator is just continuously validating for this chain. Even if no transactions come in, you're still burning that cost. So there's also advantages to doing it that way, but yeah, that's something that I think it's a pretty key economic difference between the two formulations.
Yeah, in terms of like ecosystem, I think the way I see the Atom Economic Zone, and increasingly like people are thinking about this, is they see it as this this nation of applications that are somehow complementary to each other, and will form an ecosystem of applications that leverage them, right? So they're like kind of creating their little moat right around applications like Neutron and Noble and like Skip, and maybe DAO chain, right? Well, as a utility in the Atom Economic Zone, and I think if that narrative can become stronger and really attract developers, then it'll make sense for the Atom Economic Zone to continue, because there will be increasing demand on the token, etc., and the economics will make sense. But I think that battle isn't quite won yet, and I think it's Zaki I was talking to Zaki recently, and he was saying basically like we have 12 months to figure out whether or not this is going to survive the next cycle.
Yeah, I think Cosmos has a good shot. I think the parts that confuse me, though, are like, how does it really increase demand for the Atom token, given the vast majority of Atom is staked? So like the Atom that's just sitting there lingering, what's going on with that? And like, why is that useful? And the second part is, for each additional Cosmos chain, are they really adding value to each other, or are they more like isolated communities? Because it's not like in the case of Rollup, you are all using the same layer one, and that incentivizes more people to validate for that L1, and it becomes more secure overall. There's no like network effect like that. So yeah, it makes me wonder what's the thing. I think that's a more important thing. Like, how do you build a flywheel of network effects around the Cosmos ecosystem, rather than like sovereignty is such a key feature of the ecosystem, so it might not even be possible. But rather than letting all these communities to exist in like entire independence.
Yeah, I think that's totally right. I think the flywheel question is yet to be answered, and yeah, I hope the community and the ecosystem and the projects building there kind of figure that out soon. So, what's the roadmap for Eclipse? Like, what can people expect in the next couple months, and where can people go to find out more about building on Eclipse?
Next couple months, the biggest thing is our self-service offering. So we're going to have some, because right now, all the Eclipse chains, it might be surprising because we have like 30 of these chains running, but all these teams have talked to Eclipse. They've like signed a service agreement. They've gone through like a fairly manual process, but now we want to make that whole process more scalable. So that's what we're doing right now. We're building out this offering where you just put in your credit card details or paying crypto or whatever. You can get some free trial and you can get your own Eclipse chain and try it out yourself. And that's a test net. If you want to go mainnet, you'll still have to talk to us because mainnet has some other considerations around it. You probably want to get it audited if you want any customizations, and there's other stuff that we'd want to warn you about. But yeah, that's basically the biggest thing that we're going to be doing. The other thing is historically we've done consumer, which is gaming and social, done a lot of physical infrastructure networks such as Helium type things, React, Wind. We have a bunch of those. But the last area that we've just started expanding into more is DeFi. So like constructions where block times are especially short, where it might even be like fully Ethereum aligned, where the transactions are all posted there. Historically, it hasn't made a lot of sense just because it's so expensive. But there are Ethereum apps and especially DeFi apps that have graduated to the point where it does make sense and they're just paying egregious amounts of fees for no reason. So I think we can really solve a pain point there.
Yeah, something I forgot to ask you about here is, on your website, it seems like you mentioned gaming quite a bit as a use case for Eclipse. Is that part of the go-to-market for Eclipse? And I guess the follow-up question to that would be, how big do you think crypto and Web3 gaming will become in the next cycle? Because it feels like we run an infrastructure fund. We do focus quite a bit on like the infrastructure layer, and I've noticed a drastic increase in like the amount of infrastructure projects that are talking about how their infrastructure is going to power Web3 gaming, but I have like very little kind of visibility on the gaming space. So yeah, what's coming in that space?
Yeah, part of what sparked that was in the early days for Eclipse, I was just chatting with projects in different verticals. I found small DeFi projects that wasn't really economical. NFT projects in general didn't really make sense, though we are off the record working with a pretty large NFT project, and we'll probably release a light paper on that soon. But the category where there was a lot of interest was often gaming, just because these guys were posting so many transactions on chain. And one founder, Evan at Worlds, really convinced me because he's describing how he's using the blockchain as a public or open API for his community to build additional composition on top of, whether that's financialization, build their own user-generated content, which was a huge bottleneck for many games. And it's kind of like a standardized API that people can build tooling on top of. Evan was one of the developers of Unreal Engine 5. So he's like a traditional gaming guy. And he just saw so much value in having this kind of product. So he was an early design partner for us and hammering out what does the economic structure need to look like for someone like him? And also, how can we make this generalizable for other games?
Very cool. Yeah. Great. Well, Neel, thanks so much for coming on the show today. I've really enjoyed this conversation. You've really helped me understand the architecture and like how to reason about the mental model for rollups. And yeah, it's been a great conversation.
Thanks for having me.